Good afternoon. What separates a good landing from a bad landing? A good landing is when a pilot lands safely and comfortably at the intended spot. Any landing that doesn't is a bad landing. In particular, the landing too short or landing too hard, or during landing any part of the aircraft except for the landing gear can be removed from the contact with the ground can lead to serious accidents. To make a good landing, of course, you need the good landing skill. Let's take a moment here to talk about what techniques and skills are. First, a technique is a specific way of manipulating something to perform a test. Each maneuver that says, "I do this when I land," is a technique. There are good techniques and bad techniques. A good landing technique is one that ensures you always land safely and comfortably on your intended spot. So what is a skill? A skill is the ability to operate an aircraft as intended. In other words, a skill is a technique that is intended to be used with the ability to control the path and speed of an aircraft to your liking. Skills can only be improved through experience flying in a simulator or real airplane. Good landing skills include: there are many factors that affect landings, and based on their interrelatedness, the proposed have a solid understanding of standard landing techniques. This lesson is part of the Better Landings Every Time series on the topic of This is a compilation of videos and textbooks that cover the essential knowledge and standard landing techniques needed for a safe and comfortable landing. First, let's take a look at what a landing is. At ICAO, we define our landing phrases as flare and rollout. In other words, landing doesn't end at a touchdown. A concept that includes a rollout phase that slows down to a full stop or taxi speed after a touchdown. In this lesson, we'll break down landings into 4 steps. First, final approach yung, from DA or MDA, visual segment before passing the threshold. Second, flare. Third, touchdown and rotation. And finally, rollout and deceleration 순입니다. This illustration shows the vertical path of an aircraft from final approach to rollout. If BA is maintain and approach aiming at 1,300 feet from threshold. If you don't flare and just touch down, where to ground the main gear? As you can see, it touches down at about 700 feet. The aiming point is the point where the pilot's eyes meet the runway at a 3-degree angle of descent. Therefore, the point where the main landing gear on the back of the fuselage meets the runway at a 3-degree angle of descent is well behind the ailing point. The distance delta D from the ground point of the A-inch pass to the ground point of the main gear pass is approach pitch, eye height, and it depends on the distance from the cockpit to the main gear. If you ground without a flare on approach along a normal glide path, you'll need to use the all of our machines are equipped with. You will be grounded before 10 feet. However, with proper flare manipulation by the pilot, the main landing gear of an aircraft is to safely and comfortably ground to an aiming point. Let's take a closer look at the standard landing techniques for each segment. First, the visual segment from below DA or MDA during final approach to before passing the runway threshold. To always land safely and comfortably where the pilot intended, the most important prerequisite is the stabilized approach. Stabilized approach run. The stabilization of the aircraft's attitude and speed on the on-glide path before landing maneuvers are initiated. The visual segment will use the outside reference as the primary for lateral and vertical path control of the aircraft, and the internal instrument becomes a secondary reference. So at this stage, If you lost the visual reference, go-round should be performed immediately. The main reason that the stabilized approach fails on visual segment is that the outside reference, or it is fixed to a specific reference either outside or inside. Let's see how to use the outside reference in visual segment to create the... Let's take a look at the lateral path control technique. In the visual segment, click. Without the goal of seeing what or how, blindly staring at the runway is not the same as it does nothing to control the aircraft. To control a lateral path using an outside reference, use the... First, you'll need to create a centerline, and as an extension of that, you can select a specific terrain feature and use the draw an imaginary reference line and use the... Along with this, while looking at the overall shape of the runway, set the angle of each end of the runway to continuously determine the aircraft's lateral position. If the aircraft's path is an extension of the runway centerline, then the two angles will always be the same. These outside references make it easy to recognize deviations from the planned path, allowing you to make small corrections. Early adaptation to visual references is now possible with the introduction of... It also helps with flexible landing maneuvers, especially non-precise access, etc. With the final approach course offset to the runway centerline, click the... If you are entering a runway extension or approaching with the current method in crosswind conditions, utilizing and manipulating these outside references can be done with the... You have much more flexibility to maintain the runway centerline. When referencing an outside reference for lateral control, use the relationship between glare shield and the virtual horizon allows you to use the... You can easily determine the lateral position of the aircraft. Glare-shield는, it is much larger than the airplane symbol in the PFD and located at the front of the cockpit. Since even small changes in aircraft lateral position are easily recognized, the pilots can make small corrections. You can also look at the entire outside reference and see you have the advantage of being able to control the aircraft at the same time. Even in visual segment, you don't just fly by looking at the outside reference. As stated in the FOM VScan policy, Visual Reference Contact Vuelo, PF and PMR, you need to schedule with a proper distribution of inside and outside. Even when scheduling inside, you need to be intentional about what you're checking. For example, if you're keeping an aircraft's attitude constant and you want to use if the lateral track is deviating, only when you know what's causing you can perform the appropriate modification operations to effectively scale inside. What each symbol and indication means, it should be immediately understandable. In the PFD, select the aircraft's attitude, airspeed mid-trend, wind direction and speed, heading. Taken together, information such as the lateral path can be interpreted as understand the causes and trends of lateral deviation. This is how we interpreted the correlation between inside reference and outside reference and used it to create the effort to modify the aircraft's path and airspeed is... This should happen continuously until you start flare. Before you start flare, if the aircraft's attitude and velocity have remained stable, you can use the conditions for a good landing are now met. Next, we'll discuss vertical path control with an outside reference in a visual segment. Most of our favorite airports offer IRS access procedures. Approaching the IRS right up to flare, glide slope. In other words, why not just fly along with the flight director? For accurate flare manipulation, the DA and earlier to flare, maintaining a stable vertical path is paramount. This is where outside reference comes into play. Vertical deviations are easily recognized, making it easier to recognize. Not only can you make small corrections, runway reference이 only adaptation 함으로써 allows for flexible landing maneuvers. The beam width of the glide slope, on the other hand, narrows significantly as it approaches the runway. Chasing the glide slope, even below DA, can easily lead to overcorrection. Pitch tendency due to overcorrection is a function of it also affects the hardening rate of the flare phase and Eventually, it becomes difficult to flare to a stabilized state. Therefore, for visual segments below an even fit, the glide slope or the path bit should not be chased, and set a point on the runway as the visual aiming point and use it to select the. You must maintain a constant vertical path. So what is a visual aiming point? Visual aiming point는 the target point where the pilot wants to ground the main landing gear. In visual segment from this visual aiming point, you can use the pilot's eyes meet at a 3-degree angle of intensification. Using the technique of keeping it constant at one point in the windshield, we can use you need to control the final approach path of the aircraft. 이 visual aiming point는 we usually set runway marking to reference and use the glide path that is created is based on the pilot's eyes, and the path that the aiming point on the runway takes with 3 degrees of intensification. Runway marking for setting up visual aiming points is done using it is divided into ICAO type and US type. The ICAO type of runway is at about 1,300 pit points from the threshold. The aiming point marking starts. Runway markings of the ICAO type are displayed at 500 feet intervals from the threshold. Most airports have a threshold of 1,300 feet too. I have a lungwort installed between the 1,500 pits. For Incheon Airport, a lung skin is installed at the 1,300 pit point where aiming point marking begins. 2,000 feet past the aiming point marking, 2,500 feet. Touchdown zone marking begins at the 3,000 foot mark. The last touchdown marking begins at the 3,000 foot mark, which is where you can use it as a reference for performing a go-around. The following is FAA type runway marking. Let's look at a typical FAA type runway, Los Angeles runway 24 rise. FAA type runway markings are marked with a fixed distance marking at 1,000 feet from the threshold. The lungs are installed in about 1,300 pits, and once past fixed distance marking, 1,500 fits, 2,000 feet, 2,500 feet. Each of the 3,000 pit points is labeled with touchdown zone marking. As stated in the FOM landing's normal operating procedures, our company's standard policy is, for safety, it is not grounding before 1,000 feet from the threshold. For consistent landing maneuvers and safety, we use the ICAO type. This means that the aiming point marking at about 1,300 pit points from the threshold is set to aiming point setting criteria. In actual flight, an extension of the lung sheath installed between 300 and 500 feet from the threshold and the point where the runway centerline meets you can do this by setting it to visual aiming point. At airports with FAA type runway marking, you can set the fixed distance marking shown in the cloth fit as the visual aiming point. Be careful, as it may be lower than the required approach path. Even on FAA type runway, if you have an occluder installed, you can do this by setting an extension of the alveoli as the visual aiming point. If you don't have an envelope installed, from the point where fixed distance marking ends, between the starting point of the touchdown zone marking on the 1,500 feet and make sure to set the appropriate aiming point. After setting up the visual aiming point, let's take a closer look at the vertical glide path control technique. The aircraft is on speed, in twin, and while maintaining a constant thrust, if there is no change in outside conditions, the aircraft's glide path will not change. At this point, the position of the visual aiming point in the window will be fixed. However, due to wind changes, ground effects, etc., a number of external factors can cause the aircraft may deviate from its normal glide path. This will move the position of the visual aiming point on the windshell, and this allows the pilot to recognize changes in the vertical path. With visual aiming point, even small changes in vertical path are immediately recognized, allowing you to control the aircraft's vertical path with small corrections. This is an imaginary orthography overlaid on top of the visual aiming point. As you can see, if we keep the triangle reinforcement angle constant and approach while the zone gets bigger, the center position of the zone does not move in glare shield. However, if the aircraft deviates from its normal glide path, the center of the zone will move up and down the windshield. While the aircraft is maintaining a constant pitch attitude, you can use when the aiming point hovers above the windshield, click. The aircraft is descending from its normal glide path, so pitch it up a bit and use. At the same time, it makes sure to supplement thrust appropriately so that airspeed is not reduced. Conversely, if the aiming point is below the glare shield, then the aircraft is above its normal glide path, so pitch down a bit and use. At the same time, it reduces thrust appropriately. If you continue to use trim at this point, you'll likely end up with oscillation, so we'll use in the final approach phase, the pitch trim is kept to match the third-degree reinforcement, and you need to control the pitch with the control column. As you become more proficient with visual aiming techniques, you'll be able to recognize these changes in the vertical path early on, and use the small correction allows for flexible vertical path control. You must also scale inside appropriately in visual segment. What should you look for when scheduling inside? While an aircraft's attitude and airspeed should always be known at any stage of the flight, if you are on an on-glide path with a constant attitude and velocity, you can use we need to focus on vertical speed, VSS, because it is more sensitive than the amount of pitch change in the PFD. You can see the change in the aircraft's vertical path early on. Since Samdo's glide path is a geographical path, it is closely related to ground speed, which is a reflection of wind factor. The rate of strengthening of the third degree in flight is easily calculated as a fraction of the ground speed. For example, if your ground speed is 140 knots, then the reinforcement rate for a 3-degree glide path it will be 700 feet per minute. Next, we'll look at the correlation between ILS glide slope and PP. The location of the PEPI varies somewhat from runway to runway, but typically at 1,300 feet from the threshold, it's installed between 1,500 and 1,500 feet. PEPI directs the reinforcement angle information from the pilot's eye level to approaching along ILS glide slope. Chasing PEPI below DA can change the glide path. For example, if the ILS passes the threshold with an on-glide slope state, then the PEPI will roughly dictate 3 white 1 red, whereas in a BAV with a relatively low pilot eye level, we're going to tell it to do 2 white 2 red. As you can see, the indication of the PEPI varies between conventional and pitch erythrocytes, so if the DA was maintaining a constant glide path with proper aging, the changes in the PEPI indication should not modify the aircraft's reinforcement angle. In particular, you should never chase the glide slope or PEPI indicators after passing a threshold, and you should never use you must maintain a constant hardening rate before flaring. Let's look at the correlation between ILS glide slope and PEPI indications at Incheon runway 33 rise. PEPI at runway 33 rise, Incheon, South Korea. threshold로부터 보통은 threshold로부터 safe threshold로부터 representative unlike. And until it touches down with a normal flare. Check the indications in the tappet light. As mentioned earlier, for a safe and comfortable landing, you need to use it is very important to maintain a steady glide path until the flare. However, as the aircraft approaches the ground effects tend to cause the nose of the aircraft to be heard. On most devices, ground effects are created using the. It starts to happen at about 200 feet and it gets bigger the closer it is to the ground. If the pilot fails to react appropriately, vertical oscillation may occur, or you may not be able to recover a stable glide path until you start flaring. The visual aiming method recognizes early on that the aircraft is hovering due to ground effects and uses the. It's also very useful for making corrections on the fly. With proper inside scaling with outside references, you can use the minimize changes in the glide path caused by ground effects to minimize. You can do stable flares. If it doesn't respond well to ground effects, wind changes, etc., what if the aircraft deviates from the intended glide path? If you are slightly buffed on a 3-degree glide path from the visual aiming point, but it is safe to do so, use the visual aiming point is moved forward to create the. Simply maintain the new 3rd-degree glide path until the flare. When a glide slope is 1 dot buffed at 100 feet, the aiming point for maintaining a 3-degree glide path is the. You will be moved forward approximately 230 feet. Set up a new visual aiming point by referencing the runway marking and using the. Keep a constant hardening rate until you start flaring. This time, it's lower than the normal glide path. A lower than normal glide path means that the clearance to the ground is reduced and must be corrected. Continuing to fly lower than the normal glide path is not an option for the. This is a very dangerous operation that can result in a CFIT. If for any reason you become below glide path, you can use the. Immediately return to a normal glide path and use the. Keep the original visual aiming point again. However, if a small correction is not enough to return to a normal glide path, or if a GPWS glide slope warning is issued, or alternatively, if PAPI is directing forehead, you should immediately perform a go-around. Next, we'll take a look at the airspeed control technique. By default, airspeed is a function of pitch attitude and thrust. In other words, the more airspeed you have, the greater the reinforcement for a constant glide path, and the greater the pitch attitude will be lower. Conversely, the less airspeed you have, the less reinforcement you need to maintain a constant glide path. Pitch attitude will increase. Based on this correlation, controlling airspeed should always be accompanied by proper pitch control to maintain a stable glide path. Airspeed can also change due to external influences such as wind. For example, as the headwind decreases, the airspeed decreases, so to maintain a constant glide path, thrust should be increased. If you increase thrust at this point, the pitch-up tendency occurs, so you need to compensate for this with the appropriate pitch control. Conversely, as tailwind decreases, airspeed and lift increase, so the thrust should be reduced appropriately. As thrust decreases, pitch-down tendency occurs. Try to stay as close to target speed as possible before flaring. Minimize the pitch control and click the timely recognition of changes in external factors such as wind, and controlling thrust with small corrections is critical for a stabilized approach and a good landing. If you're not able to maintain the proper thrust due to unstable airflow, you can use at a minimum, you should set an estimated thrust that is appropriate for the target speed before passing the threshold. Flaring without the proper thrust set will cause due to the rapid loss of energy as the pitch increases, this can result in a hard landing or tail speed. Next, let's take a look at flare. Flare uses the aircraft's erythritis and enhancement rate. This is a manipulation that changes the rate and reinforcement rate to be appropriate for the landing. The exact flare is aircraft's trig angle of attack to touchdown. Gradually reduce it to 1 degree. During the flare phase, the aircraft is close to the ground, so the wind shear recovery 등, outside of situations that require immediate manipulation, avoid drastic controls. If the threshold is passed and it is determined that a safe landing with a normal flare is unlikely, you should not attempt a hard landing and immediately perform a go-around. If you're more than 1,000 feet from the threshold and you're 3,000 feet from the touchdown is determined to be impossible within 1/3 of the runway length, whichever is shorter, or even if grounding is available within the touchdown zone, when in doubt about stopping safely within the remaining runway, you must perform a go-around. If for any reason drift occurs and a touchdown is questionable near the runway centerline, or even if a touchdown is possible near the runway centerline, if there is any doubt about maintaining the runway centerline after a touchdown, you must immediately go around. Flare is a visual maneuver by default. That is, for manual flare, you must have an outside visual reference. The key to flare is precise timing and proper pitch control. This requires when you pass the threshold, be sure to move your eyes from the visual aiming point you need to move it to far end of runway. This allows you to continuously determine the aircraft's approach rate to the runway surface. You'll have precise pitch control. Most hard landings are caused by the fact that even after passing the threshold, the visual shift failed and remember, this was caused by an inability to determine the aircraft's dip. You need to launch your flare at the right altitude to safely and comfortably touch down at your aiming point. The altitude to get started with flare is to use the GPWS score out is a helpful reference. Flare height by aircraft type is written as a number about altitude that takes into account the reaction time of the aircraft. B-77-200 and B-730 years aircraft are 3 hours more above the other devices. Simply listen to the selfishness callout and start manipulating flare. After starting flare, I felt like I was grounding the main landing gear of the aiming point, so I set the occupation and were constantly backframing the control column to control pitch flexibly. Keep your eyes focused on the end of the runway in the distance. At the same time, the peripheral maintains the aiming point and determines the aircraft's reinforcement rate based on the change in shape across the runway. Flare is a visual manipulation of the main source for determining the reinforcement rate at flare is visual information. The most important visual reference for determining the reinforcement rate at flare is the runway shape. This is the angle the runway sideline makes with the horizon and the change in runway width. As altitude decreases, this angle becomes smaller and the runway width appears larger. As the aircraft tightens, both runway edges are seen to rise and the angle that the runway sideline and horizon form is reduced. The larger the reinforcement rate, the faster this angle appears to decrease. These rates of change allow the pilot to continuously judge the rate of reinforcement of the aircraft. At this point, you can cross-check the GPWS callout to back up your visual enrichment judgment. During a flare, the pitch edit will increase by about 2-3 degrees at approach pitch. Gradually reduce thrust to idle while maintaining adequate back pressure to sustain the increased pitch edit. As the speed decreases, the pitch down tendency occurs, so to stay on track, you need a continuous back pressure. At this point, move the glare shield over If you adjust the virtual horizons to be evenly spaced, you can use allows for proper pitch control. If your aircraft started flare in the stabilized state, you can use the pitch control during flare requires only a small amount of flexible back pressure adjustment. Trim should not be used during flare. If the aircraft dips rapidly during a flare, give the control column a little more back pressure and wait. Conversely, if the aircraft does not strengthen or hover, Release the back pressure on the control column slightly and wait. If it was a correct flare, the aircraft would return to the idle position when the thrust is in the. We will ground the visual aiming point part at the VRF velocity. If it doesn't ground past the aiming point, release the back pressure on the control column slightly. Keep your eye on the far end of runway and feel the approach rate to the runway in your peripheral vision. Control the reinforcement rate until touchdown. You shouldn't keep increasing the pitch to make the perfect smooth touchdown. Flare timing is too early or too late? Alternatively, if the amount of flare is too high or too low, this can result in a hard landing or a bounced landing. Therefore, flare will start at the appropriate altitude and use the. It's important to create pitch changes with a consistent rhythm. Let's take a look at a video of a BASS aircraft landing to illustrate what we've discussed so far. From launching flare to rolling out. Relationship between virtual horizon and glare shield. To see the change in pitch. From threshold, which is an extension of evade, to intrigue while maintaining a stable attitude and airspeed. As you pass the threshold, switch your view to the far end of the runway and click the. The peripheral vision is feeling the angular changes that runway sideline and horizon are making. In flare height, set a positive back pressure on the control column to. The attitude change of the subject aircraft has begun. This change in attitude must occur when you pass flare height. After the posture change starts, while gradually retarding thrust, you've created the right pitch edit for landing. The buff rate and speed are reduced simultaneously and it is giving more back pressure to maintain the landing attitude. While viewing the overall shape of the runway in your peripheral vision, you can adjust the back framer to create a grounded the main landing gear of the aiming point. We flexibly release the back pressure on the control column to ground the north gear to the runway. Today we'll look at flare techniques for crosswinds. Crosswind landing technique는 decrep during flare, touchdown in crep. There are 3 wing-low methods. At our company, we use the decrep during flare method, which is safe and easy to operate. We've adopted this as a standard technique. The decrep during flare technique is characterized by avoid overcorrection for altitude-specific wind changes, approach flare, and that the wings level of the aircraft is always maintained during touchdown. Let's take a closer look at the decrep during flare technique. First, in the approach step, set the wings level to, while maintaining the upwind crep angle. Match the aircraft's path to an extension of the runway centerline. Once the aircraft has drifted downwind in crosswind conditions, it becomes very difficult to get back in as an extension of the runway centerline. Therefore, it is very important to maintain an accurate extension of the runway centerline. Especially in strong crosswind conditions, you should not allow even the slightest downwind drift. After starting flare, flexibly use the rudder downwind of the. Match the aircraft's nose axis line to the runway centerline. This will result in a downwind roll, so for the wings level, make sure to use the windward aileron appropriately. Also, the aircraft will sink proportional to the amount of decrep. Only by maintaining the outside visual reference described earlier can you use the blessing of the aircraft and bank, and you can determine the amount of subsidence at the same time. If you experience a small amount of downwind drift due to decrep timing being too early, lack of aileron use, etc., perform modification manipulations with order in a bank. However, if the drift is not corrected, or if you suspect a safe grounding and rollout within the touchdown zone, you should go around immediately. Once you have a proper decrep, the aircraft will be in wings level, with both main gears grounded to the runway at the same time. During the rollout phase, as many rudder and continue using aileron. Next, we'll discuss flare techniques for headwind or tailwind. First, you'll see the approach video in headwind 30 knots lightweight and let's compare the approach footage in tailwind 15 knots heavyweight. See the difference? Basically, the flare techniques are not different for each wind. As you can see, the shape change of the runway during the landing gear path and flare is the same for both the headwind 30 knots and tailwind 15 knots cases. However, in tailwind conditions, the ground speed is relatively high, resulting in a larger VS and the flare duration will be shorter. Therefore, you can use the more flare manipulation you need to do, the sooner you can reduce thrust. Mechanical manipulation of flare with a constant force, without judgment of the hardening rate via an outside reference, is not sufficient for we can't adequately respond to these changes in the wind. On the other hand, if you always flare an outside reference as primary, ensure consistent and accurate flare operation, even when the external environment changes. Let's take a look at early flare and late flare. First up is early flare. On the left is a video of the flare manipulation starting and floating before the flare height. The screen to the right shows a normal flare maneuver with the main landing gear grounding to the aiming point. If for any reason you are unable to use early flare, or due to excessive flare manipulation, if the aiming point is not grounded and is floating, it releases the back pressure slightly and creates the right amount of reinforcement. Otherwise, if you try to force yourself to ground at your planned landing spot, you'll need to reducing thrust and creating a deeper reinforcement angle can be done by using you run out of energy and risk a hard landing. Once the proper hardening rate is maintained by releasing the back pressure slightly, see runway marking for more information about continue maneuvering flare to touchdown within the restricted area. However, if you're using or it is determined that grounding is not possible within 1/3 of the runway, or the aircraft is in a steep dive and if you are unsure of a safe landing, you should immediately perform a go-around. Next up is late flare. Most of the hard landings we've had at our company have been due to late flares, and we've seen a lot of them. The main reason for this is that the visual shift failed to pass the threshold. Keep in mind that flare is all about timing. To avoid late flares, the most important thing to remember is to use in DA and below, use the outside visual reference as primary, maintain a constant glide path and use the idea is that when you pass the threshold, you must visual shift to the far end of the runway. In addition to that, flare doesn't support runway widths or nighttime, or visual illusion due to undercorrection, sometimes affects the determination of an aircraft's exact altitude or enhancement rate somewhat. If you cross-check your GPWS callouts well, you can minimize these visual illusions and have consistent flare operations. If abnormal flare manipulation results in high bouncing beyond autofit, you can use perform a go-round immediately, as a safe landing may be jeopardized. For more information about bounced landing, click the icon at the bottom. Next, we'll look at the backward rotation technique. When the main landing gear touches down on the runway, when the thrust lever must be in the idle position. If the thrust lever is in a position other than idle, the thrust reverser will not work. If the speed brake is not extended, the initial braking effect is reduced by 60%. After confirming that speed brake is up, click. While enabling thrust reverser, you can also use without delay, and you need to be flexible and put the nose wheel down on the runway. The operation to ground the nose wheel to the runway is done using it is enough to slightly release the back pressure that was held on touchdown. After main landing gear grounding, If you slide the control column forward, the ground impact of the nose wheel causes the... Be careful, as this can cause structural damage to the aircraft. After the touchdown, directional control uses weather to maintain the runway center line. During crosswind landings, you can use the control columns into the wind as much as needed to maintain wings level to help steer. Do not use nose wheel steering until you are at a safe taxi speed. During landing, it is very important for pilots to recognize where they have touched down. If you don't touch down at the intended point, you can use the "it may not be possible to roll out safely on the remaining runway." This is especially true if you're close to meeting landing performance, or if you're using if the runway is covered with water, snow, etc. Rollouts can be more critical than touchdowns. Because the remaining runway conditions may not be what the pilot predicted, unless otherwise restricted, you should not intentionally delay deceleration. If a pilot mistakes their position on the runway, they can use the "it may not be possible to open the runway with a safe taxiway." So after landing, the runway markings and signs, runway distance markers, runway lights, etc. You should constantly check your position and remaining runway distance using all available information. To manually brake by looking at the remaining distance after landing is to use the "it's like you didn't plan for landing" performance. If the aircraft's aura brake system is functioning properly, always use aura brakes. If you don't ground at the planned touchdown point, or if you don't ground at the runway conditions are not as predicted. If you are in doubt about safe deceleration on the remaining runway, you should immediately switch to the manual brake. If you use aura brake to slow down normally, you can use to prevent brake jerk at low speeds. Before taxi speed, gently depress the brake pedal to disengage the aero brakes. And keep applying the brakes as long as you need to. Please maintain a safe taxi speed. Do you remember which landing was a good landing? Yes, at the point the pilot intended. Secure? A soft landing is a good landing? We hope this lesson on standard landing techniques will help us all improve our landing skills. Check out bounce landing recovery in summary. Let's take a look at bounced landings during landing. Bounced landings are those that have a high reinforcement rate or often occurs when the thrust is above idle at the time of grounding. If the thrust is reduced to an idle during bouncing, the additional loss of lift causing the aircraft will have a greater buff rate. At this point, the pilot instinctively increases pitch, often resulting in a borne strike. Because hot landings due to loss of lift can occur even if a berth strike does not occur, depending on the degree of bouncing, you should perform the appropriate recovery maneuvers. A bounce landing is a light bouncing within an office, and it can be broken down into high bouncing, which is more than an octet. Most of the light bounce felt by pilots is due to firm landings. The main gear strut is extended and it may not have actually bounced. If light bouncing occurs, continue the landing maneuver by maintaining the normal landing attitude. Further increasing the pitch after bouncing can result in a borne strike. After bouncing, to adjust the hardening rate to secondary ground, use it may increase thrust slightly, but for most light bouncing, an increase in thrust is not required. This time, it's high bouncing over an octet. If you experience high bounces of more than an order of magnitude, you can use because a safe landing is not possible on the remaining runway, you must do a go-around. However, once you've used the reverser, under no circumstances should you do a go-around. If high bouncing occurs, stay in the landing position and use increase the thrust to the tower. Increasing thrust causes pitch-up tendency, so you should use it's very important to keep your landing pitch intact. most bird strikes that occurred during a bounce landing were caused by the after-date bouncing, while using toggles for go-around the failure to control pitch-up tendency, or remember that this was caused by a sharp rotation manipulation. After the toggle, while maintaining the landing pitch, use the once in a steady positive climb state, gradually rotating to a go-around pitch and then to a perform normal go-round operations. So let's wrap things up. First, good approach makes good landing. DA or lower until it passes the threshold. Stabilized approaches have an absolute impact on landings. With minimal pitch and thrust changes, as close to target speed as possible, maintain stable parts. Second, keep the parts of the aircraft stable by priming the outside references until flared. You should not chase PEPI or IRS glide snobs below DA. Third, as you pass the threshold, move your primary view to the far end of the runway and click the Start Flare at the correct altitude. The virtual horizon and overall runway shape change with the peripheral vision. Determine the reinforcement rate. Fourth, flexibly control pitch and thrust to keep the main landing gear grounded at the aiming point. Adjust the reinforcement rate. Finally, if the main landing gear is grounded, without delay, and you have the flexibility to fly your noseway down the runway and to use decelerate to taxi speed while maintaining the runway centerline. Based on what we've covered so far, let's take a look at the standard landing videos for each device.